Hello and greetings. This is Dr. VC Sontake and I am going to take the course Heat Transfer. Objective of this video lecture is to derive the expression of LMTD for condenser and evaporator type of heat exchangers. Condenser and evaporator are one of the type of heat exchangers where one of the fluid, that is from hot and cold fluid, undergoes phase change process. The phase change process can be condensation or evaporation, whereas other fluid undergoes change of temperature. So let us derive the expression of LMTD for condenser and evaporator type of heat exchanger. Log mean temperature difference for condenser. So what do you mean by condenser? Condenser is a type of heat exchanger in which, due to heat transfer between hot and cold fluids, hot fluid undergoes condensation process. In condensation process, hot fluid undergoes phase change process from vapor phase to liquid phase at constant temperature. That is, during heat exchange process, the temperature of the hot fluid at the inlet and outlet are constant, that is Thi is equal to Tho. During condensation, heat transfer from hot fluid to the cold fluid takes place in the form of latent heat of condensation. In condenser, heat transfer to the cold fluid serves as a sensible heat, that is, the heat which is transferred from hot fluid to the cold fluid, it will be served as sensible heat and will increase the temperature of cold fluid. In condenser, heat capacity rate of hot fluid is taken as infinite, that is capital C H, which is the product of m dot H into small cph, tends to be infinity. Hence, the LMTD expression for condenser in the most generalized form can be given as delta Tm is equal to delta To minus delta Ti over log of delta To over delta Ti, which can also be written as delta Ti minus delta To over log of delta Ti over delta To, where delta Ti is the temperature difference between hot and cold fluid at the inlet of the heat exchanger, and delta To is the temperature difference between hot and cold fluid at the outlet or exit of the heat exchanger. So let us discuss the temperature variation of hot and cold fluid in condenser. To do so, let us consider figure 1, and the figure 1 represents temperature distribution of hot and cold fluid in a condenser if the direction of both the fluids are in parallel direction. So let us consider in this plot, on x-axis area of the heat exchanger is considered, and on y-axis temperatures of both the fluids are considered. Let this point represents inlet of the heat exchanger and this vertical line represents outlet of the heat exchanger. In case of condenser, hot fluid will be condensing fluid. Let's say its initial temperature, that is inlet temperature, is Thi, and cold fluid at inlet temperature Tci. When hot and cold fluids are flowing in a heat exchanger, due to heat exchange, hot fluid undergoes condensation at constant temperature, so its temperature will remain constant from Thi to Tho. So temperature variation of hot fluid in case of condenser is not going to change, hence it is shown by horizontal line. Whereas because of receiving of heat by cold fluid, its temperature will be increasing from TCI to TCO, and direction of fluid flow will be from inlet to outlet. Similarly, figure 2 represents the temperature distribution in counterflow condenser. Once again, hot fluid will be condensing fluid at the inlet temperature Thi, and cold fluid will be the second fluid at initial temperature Tci. Since the direction of flow of fluids is counterflow, hot fluid will be entering from the left hand side and cold fluid will be entering from the right hand side. During passing through the heat exchanger, heat exchange takes place between hot fluid and cold fluid. By virtue of this heat exchange, hot fluid undergoes condensation process at constant temperature. So temperature of the hot fluid remain constant, that is Thi is equal to Tho. Cold fluid enters from the right hand side and it receives heat from the hot fluid, and as a result of this heat, its temperature increases from Tci to Tco. So this way, the temperatures of hot and cold fluid changes in a condenser if parallel flow arrangement is employed and counter flow arrangement is employed. So for condenser, heat capacity rate of hot fluid is considered to be infinity, and Thi is equal to Tho is equal to Th. So for parallel flow, temperature difference at the inlet delta Ti will be Thi minus Tci, that will be Th minus Tci, and temperature at the outlet of the heat exchanger delta To will be Tho minus Tco is equal to Th minus Tco. For counterflow heat exchanger, the temperature difference at the inlet will be Th minus Tco, and temperature difference at the outlet of the heat exchanger will be Th minus Tci. So this way I could get the expression for LMTD of condenser. Then log mean temperature difference for evaporator. So what do you mean by evaporator type of heat exchanger? Evaporator is a type of heat exchanger in which, due to heat exchange between hot and cold fluid undergoes evaporation process. Now what do you mean by evaporation process? In evaporation process, cold fluid undergoes phase change process from liquid to vapor at constant temperature, that is Tci is equal to Tco. During evaporation, heat transfer to the cold fluid takes place in the form of latent heat of vaporization. To convert liquid into vapor, we need to supply heat to the cold fluid, and that heat will be in the form of latent heat of vaporization. In evaporator, heat transfer from the hot fluid takes place in the form of sensible heat, that is, it decreases the temperature of the hot fluid. Heat capacity rate of cold fluid in case of evaporator is taken as infinite, that is capital C suffix C, which is the product of m dot C into small cpc, tends to be infinity. So this is the general expression of LMTD for any type of heat exchanger in terms of temperature difference between the hot and cold fluid at the inlet and at the outlet respectively. Now, like what we have discussed in the previous slide for condenser, I can extend same discussion to the evaporator as well. That is how temperatures of hot and cold fluid will be varying in evaporator with parallel flow arrangement and counter flow arrangement. So figure 3 represents temperature distribution in parallel flow evaporator. In case of evaporator, first fluid will be the hot fluid and its temperature at the inlet of the heat exchanger is Thi. Cold fluid will be the boiling fluid or evaporating fluid, and let's say its inlet temperature is Tci. When heat exchange takes place between hot and cold fluid, temperature of the cold fluid will be decreasing from Thi to Tho. However, the cold fluid after receiving heat from the hot fluid will undergo phase change process from liquid to vapor at constant temperature. So its temperature will remain constant, that is Tci is equal to Tco, and hence it is represented by horizontal line. So figure 3 represents temperature distribution of hot and cold fluid in parallel flow evaporator. Then figure 4 represents temperature distribution of hot and cold fluid in counterflow evaporator. First fluid will be the hot fluid. Let's say its inlet temperature is Thi and hot fluid is entering from the left hand side. Since it is a counterflow heat exchanger, so cold fluid, which is a boiling fluid at an inlet temperature Tci, will be entering from the right hand side. By virtue of heat exchange from hot to cold fluid, temperature of the hot fluid will be decreasing from Thi to Tho, and cold fluid after receiving heat from the hot fluid will undergo phase change process at constant temperature, that is Tci is equal to Tco. So this way the temperatures of hot and cold fluid vary in evaporator when parallel flow and counter flow arrangements are employed. So for condenser, heat capacity rate of cold fluid, that is capital Cc, will be infinite and Tci is equal to Tco is equal to Tc. So for parallel flow, delta Ti is equal to Thi minus Tc and delta To is equal to Tho minus Tc. For counter flow, delta Ti will be Thi minus Tc and delta To will be Tho minus Tc. So this way I could get the expression for LMTD of evaporator. Learning outcomes of the video. After watching this video, the learner will be able to derive the expression of LMTD for condenser and evaporator type of heat exchanger in parallel and counter flow heat exchanger. So with this I come to an end of this video lecture. Thank you very much for your kind attention and passionate listening. Happy learning.